Good morning everyone. This is Dr. Murali from India. Now I am going to explain various cochleostomies and cochlear drill outs. This is the cochlea here. This is the cochlea here, and this is the labyrinth. Let me explain this cochleostomies and cochlear drill outs. Let me focus closer. Yes, this is the round window area. And this is the oval window here. This round window, this leads to the scalar tympani. So we make antero-inferior cochleostomy, or Dr. Satish Jain advocates inferior cochleostomy, and when we drill in the direction of the outer wall of the cochlea, this is the outer wall of the cochlea here. This is the hypotympanic cells. When you don't identify the round window, there are two things. One is the fustis, this is the fustis here, and when you drill the hypotympanic cells, you identify the ivory bone of the outer wall of the cochlea. This is the outer wall of the cochlea, OWC. So then if you make cochleostomy, that leads to scalar tympani. Here, after drilling out of this scalar tympani, basal turn drill out, the scala vestibuli is lost. Just above this, over the osseous spiral lamella, you will see the scala vestibuli. Now in the basal turn, there is no demarcation in this specimen between the scala vestibuli and the scalar tympani. And this is the oval window. And first we have to do scalar tympani cochleostomy at antero-inferior part of the round window, and if you drill out that in the direction of the outer wall of the cochlea, it becomes the scalar tympani drill out. Next is how to make scala vestibular cochleostomy. If you make a cochleostomy between the oval window here and the round window here, in between here at the midpoint, it becomes the scala vestibular cochleostomy. If you drill the scala vestibuli in the lap of scala tympani, it becomes scala tympani drill out. In this specimen, after drilling out, after doing exercises, both the scala tympani and scala vestibuli fused together, as osseous spiral lamella is also injured here. Now, what about scala middle turn cochleostomy? Just 1 mm anterior to the anterior border of the oval window here, that becomes the middle turn cochleostomy. In the middle turn cochleostomy, scala vestibuli is larger than scala tympani, whereas in the basal turn, scala tympani is larger than scala vestibuli. Now I have to make a middle turn drill out in the lap of scala vestibular drill out. So first I will make the scala tympani drill out. In the lap of scala tympani drill out, I will make the scala vestibular drill out, and in the lap of scala vestibular drill out, I will make middle turn drill out. And next, how to identify the superior turn cochleostomy. Superior turn cochleostomy present in the groove of the tensor tympani, here just above the process cochleoformis. Here the facial nerve is, this is almost very long preserved bone, so we lost the facial nerve in the preservation itself. So this becomes this is the oval window, just above that is the second genu, This is the horizontal part of the facial nerve. And it turns backwards, that becomes the labyrinthine part of the facial nerve. And that in the previous video I showed you, this labyrinthine part of the facial nerve is present between the cochlea and superior semicircular canal. And what is Perseus triangle or dangerous triangle? Why we should not do this middle turn cochleostomy not more than 2 mm anterior to the anterior border of the oval window. If I do more than 2 mm anterior to the anterior border of the oval window, when I am going bird deeper, my cochleostomy, when I am doing cochleostomy, my burr may hit the labyrinthine part of the facial nerve, which is present in the roof of the middle turn cochleostomy, middle turn drill out. So it present here. Now here the labyrinthine part goes backwards like this. So I made a hole from here. So tomorrow I will show in the video, if I pass a ball probe here, it comes into the middle turn cochleostomy. So in post-operative, after doing cochlear implantation, if the patient presents with facial twitchings, you have to see whether this part of the electrode is stimulating the labyrinthine part of the facial nerve. So we have to switch off that electrode. Or in malignancies, when we are drilling this triangle, that is Perseus triangle or dangerous triangle, which is formed by the superiorly by the horizontal part of the facial nerve and posteriorly by the anterior border of the oval window and inferiorly by the Jacobson nerve, that triangle becomes the Perseus triangle or dangerous triangle. So that is the reason when I am doing middle turn cochleostomy, I drill just 1 mm anterior to the oval window. Okay. Then the leftover point is, when we are confused with the identification of the round window, one point I told you, drill the hypotympanic cells, identify the ivory bone of the outer wall of the cochlea, and then make a cochleostomy into the scala tympani. Another important point is fustis. This fustis is like a hill present coming from retrotympanum towards the round window. Here this is the fustis. This fustis directs towards the round window. The space above this fustis is called concomerata medialis. The space below this is called concomerata lateralis. If I drill inferior to this fustis, I reach the subcochlear tunnel. Previous surgeons, they used to call it hypotympanic cell. So this is a big trap. There are so many case reports the electrode is passed into the subcochlear tunnel. So how to avoid that? The only way is to identify the fustis. So we have to make a cochleostomy by staying above this fustis at anterior-inferior area to the round window. But Dr. Satish Jain is saying is, stay a little bit inferior to the anterior-inferior, that he is calling as inferior cochleostomy. As you pass electrode, it is a direct trajectory to the scala tympani. So he is directly avoiding the hook area. What is hook area? Hook area consists of 3 parts. The basal, proximal most basal part of the osseous-spiral lamella, and the crista fenestrae and crista semilunaris. Crista fenestrae is this thick part of the bone at the starting point of the basal turn of the cochlea. Crista semilunaris is small ridge of bone at the base of the round window. Here this is the crista semilunaris. And here in this bone, the osseous-spiral lamella, proximal most part of the osseous-spiral lamella is injured in drill outs. So the osseous-spiral lamella attaches to the superior border of the oval window. So when you are making a cochleostomy, first drill the inferior lip of the round window and then only make a cochleostomy. When you are drilling the superior lip, posterior superior lip, you have to be very careful, as posterior superior membrane of the round window membrane, posterior superior part of the round window membrane is very near to that. Tomorrow I will release another video. The light is switched off in the cell phone. Thank you. Bye.